Hey everyone, today we are looking at 7.1, which is ratios in similar polygons. So first things first is, what does similar mean? Similar figures are figures that are the same shape, but not necessarily the same size. Okay, so when we did congruence was same size, same shape. With similarity, it's still the same shape, it's just a different size. So if we look over here at triangles 1 and 2, they look like they're both isosceles triangles. They look like they're the same shape. It's just that it looks like 2 is bigger than 1. Okay, so those would be similar. If we look over here at 1 and 3, okay, this triangle 1 is the same as this triangle 1. But notice that this looks like it's isosceles and then this is right. These are not the same type of triangle. They are not the same shape triangle. So they're both not the same shape and different sizes, so they are not similar. All right, so one thing that I want you to notice is the symbol that we use for similar is right here. That is a tilde. Okay, so I can say that triangle 1 is similar to triangle 2. Okay, or I can put a slash through it for not similar. All right, so if there's any questions about that, make sure you are making notes on your paper and we will get those answered. But let's take a look at a little more at what similarity means. Okay, so if I have two figures that are similar, okay, their corresponding angles are congruent, their corresponding sides are proportional. So let's think back for a second when we did congruent triangles. And we said that when we knew that our triangles were congruent, or congruent figures we had, or if we had congruent figures, we knew that all the pairs of angles were congruent, all those matching angles. That doesn't change with similarity. So if I look here, angle A and E are corresponding angles, and they're both right angles here, so they are congruent. Angle D and H, same thing. They are both going to correspond, and they are congruent. If I look here, B is going to correspond with F, they're congruent, and angle C is going to correspond with angle G, so they are congruent as well. So if we look over here, all my pairs of corresponding angles are still congruent. Now, with congruent figures, our corresponding sides were also congruent. We're going to change that up a little bit here with similarity, and we're going to say that our corresponding sides are proportional. So what that means is that if I take the sides in one figure and I put them over the sides in the other figure, they will all reduce to the same fraction. So if I look at AB over EF, that is 6 over 12, which is going to reduce to 1/2. So I'm doing little figure over big figure, okay? So 6 over 12 is 1/2. If I look here at AD and EH, that is 5 over 10, which is also 1/2. CD and GH is 4 over 8, which is also 1/2. And BC over FG is 5.4 over 10.8, which is also 1/2. So each side length is a different length, but when I put my small side over its matching big side, they will all reduce to the exact same fraction. That's what it means to be proportional. So when I look over here, I have that fraction, that AB over EF, BC over FG, CD over GH, DA over HE, all of those fractions equaled 1/2. So what this is called here with all of my side ratios is an extended proportion. When I'm writing, all the sides their ratios are equal, okay? Remember, AB over EF is a ratio, okay? So when I'm looking here, my extended proportion has in the numerator, all of these are the small figure. In the denominator, this is all the larger figure. Now, it does not have to be small over large. It could be large over small, and then my similarity ratio would have been 2 over 1. But the important thing here is that I have the same figure in the top, the other figure in the bottom. You cannot mix and match those. It's very important that you keep a consistent figure in the numerator, a consistent figure in the denominator. All right, so let's take a look. We're looking at these two triangles here, and I want to identify all of my pairs of congruent angles and all of my corresponding sides. So what I'm going to start with is looking at my corresponding sides. But sometimes with similar figures, it can be a little difficult to see what matches up with where because they are different sizes. So what I'm going to do is when I'm looking at my sides, I'm going to find my smallest side. If I'm looking at this figure here at triangle QRS, 9 is the smallest side length. Okay, so I'm going to label that as S for my small side. My 13.5 here is the next biggest side, so I'm going to label that as M for my medium length side. And then QR here is 18, so I'm going to label that as L for the longest side. Then I'm going to come over here and do the same thing. So over here in this triangle XYZ, 6 is my smallest side. Okay, 9 is the middle side, and 12 is the longest side. So doing this allows me to match up my small sides easier. So my smallest side over here is QS. So QS and my smallest side over here, which is XY, those are going to be corresponding sides. Okay, then I'm going to do the same thing with my medium length sides. SR is my medium length side over here. So it'll be SR, and my medium side over here is XZ. And then I'm going to take a look at my longest sides, which in the first figure is QR, which is 18. So QR. And my longest side over here is YZ. So those are all of my corresponding sides by using their side lengths to help me match them up. Okay, then we're going to look at our corresponding angles. My 1 arcs are going to be R and Z. So angle R is going to be congruent to angle Z because again, in your similar figures, your angle measures are still congruent. All right, my double arc here is Q, my double arc here is Y, so angle Q will be congruent to angle Y. And then my one without any arcs is S and X, so angle S is congruent to angle X. And again, we know that these are congruent because we can use our third angle theorem if we need to. Because remember, in a triangle, if you know 2 pairs are congruent, then the third pair must also be congruent. Okay, so that's our third angles theorem, but they're going to correspond as well. All right, so if you have any questions on that, please make note of it. All right, we are going to look right now at what a similarity ratio is. Okay, a similarity ratio is the lengths of the corresponding sides of our polygon. So if we come back here to this second slide for a second, remember when we did, 6 over 12 was 1/2, 5 over 10 is 1/2, 4 over 8 is 1/2. Well, the similarity ratio of my small figure to my big figure is 1/2. So when we're doing this, we're going to look at the same thing. Okay, so if I'm looking here at ABC 2 DEF, remember that this word 2 tells you the order in which you're supposed to look at your figures. So that means that ABC is going to go in my numerator and DEF is going to be in my denominator. Okay, so ABC is all my sides are 3, DEF all my sides are 6. So I'm going to do 3 over 6, which is 1/2. Now, if I do my similarity ratio the other way of my big triangle to my little triangle, it'll be 6 over 3 or 2. And you can also say 2 to 1 if we're looking at that. Okay? Remember, we can write a ratio as 1/2. We can write a ratio as 1 to 2. Or we can say 1, 2, 2. All right? All 3 of these are different ways that we can write the ratio 1/2. All right, if we're writing the ratio 2, we should really be saying 2 to 1, 2 to 1, or 2 to 1. Okay, so a little reminder there. We talked about that. But again, so you make sure you're paying attention to which figure you're doing first because that will make a difference in your ratio. All right, so let's take a look at example 2 here. And I want to determine whether or not these polygons are similar. All right, so I'm going to look here at A. I have rectangles PQRS and TUVW. First things first is we need to pull all that information that we did in chapter 6 with our knowledge base about what do we know about rectangles. Well, we know in the definition of a rectangle that it has 4 right angles. All right, so I'm going to go ahead and label these as 4 right angles. All right, We also know that a rectangle is still a parallelogram, so opposite sides are congruent. So if PQ is 12, then SR is 12. If PS is 4, then QR is also 4. Right? If TW is 6, then UV is 6, and if TU is 16, WV is also 16. So now, to determine whether or not our figures are similar, we need to hit two checkboxes. We need to have all of the pairs of angles are congruent. So when I look here, all these pairs of angles are going to be congruent to all these pairs of angles because they're all right angles. So we know that all the pairs of angles are congruent. So that's like a checkbox for us right there. We needed to know that. Okay, the next thing that we want to do is determine whether or not the sides are proportional. So what I'm going to do, because opposite sides are congruent here, I only have to do two pairs of sides. So I'm going to do 4, which is PS. Now the side that's going to correspond with PS is going to be TW over here. So it'll be 4 over 6. And I want to know whether or not that equals my longer sides, which is going to be 12 for my smaller figure and 16 for my larger figure. Again, notice that I did smaller figure on top, larger figure on the bottom. Okay, so now what we're going to do is we are going to reduce both of these fractions. So 4 over 6 is going to reduce to 2/3. And 12 over 16 is going to reduce to 3/4. These are not equal. So because these are not equal, that means that my rectangles are not going to be similar. So we can say that PQRS is not similar to TUVW. All right, so again, they're not similar because even though all the angles are congruent, their sides are not proportional. So we're going to go over here now and take a look at part B. With B, I'm going to start off by doing the same thing that we did before, as I'm going to start by looking at my angle measures, okay? I know that angle A is congruent to angle D because those are marked. I know that angle B is going to be congruent to angle E. And I know that angle C will be congruent to angle F. Now, why do I know that C and F are congruent? Again, that is my third angles theorem. That is how I know, because I know that two pairs of angles are marked congruent, so that means that the third pair must also be congruent. So I know that all of my angles are congruent. That is a check mark that I need. The next thing that I'm going to do is determine whether all of my sides are going to be proportional. So I'm going to start by, again, like we did in the last example, we're going to look at labeling our sides as small, medium, and large so I can put them in the right ratios. So in this triangle, 16 is my smallest side, 20 is the next longest, and then 24 is my longest side. Same thing over here, 12 is my smallest side, 15 is my medium length side, and 18 is my long side. So what I'm going to do is I'm going to put my left triangle over the right triangle. So everything that I'm going to do here is I'm going to set up my larger triangle over my smaller triangle. And I'm going to do this to help keep me organized. All right, again, it doesn't always have to be small in the numerator. So my smallest side for my large triangle is 16. My smallest side for my smaller triangle is 12. I want to know whether or not that is going to equal my medium side, which is 20, over my medium side, which is 15. And I want to know, does that equal my longest sides of my biggest one, which is 24, over my smallest one, which is 18. So every single one of these fractions has the larger triangle in the numerator, the smaller triangle in the denominator. All right, so 16 over 20 is going to reduce to 4/3. 20 over 15 is going to reduce to 4/3. And 24 over 18 is also going to reduce to 4/3. So because they all reduce to 4/3, 4/3 is going to be my similarity ratio. Since all of the sides are proportional, all of the angles are the same measure, my triangles are going to be similar, and 4/3 is going to be my similarity ratio from my large triangle to my small triangle. Okay, if you did it the other way around, 3/4 would have been your similarity ratio, and that would be fine because it doesn't tell you in this problem which way to write your similarity ratio, whether you're writing large to small or small to large. Either way is fine because, again, it does not specify. All right. So then the next thing that we need to do, because we wrote our similarity ratio, is then we need to write a similarity statement. So our similarity statement is just like our congruent statements. We have to match our angles. We have to make sure our sides are corresponding. But instead of our congruent symbol, we are writing our similarity symbol. So I'm going to start with triangle ABC, and it is going to be similar to triangle. Now, angle A is going to match with angle D. Angle B is going to match with angle E. And angle C is going to match with angle F. So ABC is similar to triangle DEF. So again, in order to prove similarity, you have to have all of your pairs of angles are congruent and all of your pairs of sides are proportional. All right, so if you have any questions on that, go ahead and write them down on your papers now. All right, let's go ahead and look at example 3. All right, so with example 3, we have a rail box car, so a train car, can be used to transport auto parts. If the length of the actual box car is 50 feet, we want to find the width of the actual box car to the nearest tenth of a foot. So what we're going to do here, I'm actually going to kind of shrink this up a little bit to make it look like it's going to be a model. And I'm going to copy and paste it. So what you may want to do is just sketch like another rectangle on your paper so you can kind of see what we're looking at. All right. So this won't be 7 inches and this won't be 2 inches. All right. So what we have here is the length of our boxcar. The model is 7 inches. So I'm going to write L is equal to 7 inches. My L's are getting wonky. L, there we go. Okay, that's going to make my width 2 inches. All right, so the length of the actual boxcar is 50 feet, and the width is what we're looking for. Okay, so when you do a model, okay, so right here we have a model of the boxcar. When you do a model, it will always be similar to the actual size, okay, to the actual figure. So I know that this boxcar is going to be similar to the real thing. So what I'm going to set up here is I am going to set up a proportion where I'm going to put the model over the actual figure. So I'm going to do the smaller one to the larger one. All right. So the width or the length of my smaller figure is 7 inches. The length of my larger figure is 50 feet. I don't have to worry about units here because I'm going to go, this is inches, inches, this will be feet, feet, it will be fine. You don't have to convert anything, it's fine. All right. The width of my model boxcar is 2 inches. And the width of my actual boxcar is what I'm looking for. All right, so I'm going to cross multiply here. 7 times W is going to be 7W. 50 times 2 is 100. And I'm going to divide both sides by 100, so I'm going to get 100 over 7. Now, it says to the nearest tenth of a foot. So I'm going to put that in my calculator, so that'll be 14.2857, . Okay, if I'm going to the nearest tenth, a reminder, this is my tenths place. The only number I look at to round is the one directly behind it, so I don't care about any of these. So 8 rounds up, so my width will be 14.3 feet. All right, if you have questions on anything, make sure they get down on your papers and ask me in class when I see you. So have a wonderful evening, and I will see you guys later.